Good morning and good afternoon. Thank you for joining our webinar today on uses for escape devices in the first responder market. Our product manager, Tom Williams, will be providing an overview on escape devices and scenarios. We ask that you submit questions throughout, and all questions will be answered at the end of the presentation. And I will now pass it over to Tom Williams.
Thanks, Molly, and welcome everyone to today's webinar, and I hope everyone's doing well. So as you've hopefully seen and heard, today's webinar is focusing on the uses of escape devices in the first responder market. So the aim of today is to frame the use of escape devices in the context of the different respiratory threats faced by first responders and investigate why an escape device, like an escape hood, for example, is an appropriate respiratory protection solution for these situations and the advantages that they offer to users. As Molly mentioned, I will open up to questions at the end of the session, so do feel free to submit questions throughout via the question bar on the right of your screen, and I'll do my best to answer those at the end of the session. So when looking at different types of respiratory protective equipment, or RPE, it's important to understand this in the context of some of the different types of respiratory threats faced by global first responders. I'm going to share on screen, and hopefully you can see that, a variety of different events, some of which you may recognise from global news images, for example, which perhaps led to a respiratory threat of some form, whether that be via a deliberate event, like in the case of a terror attack, or by some kind of accidental release. Whereas others that you'll see are sort of more common events or incidents that first responders may actually respond to. So starting off with the image in the top right-hand corner, which was taken from the riots in the United States last year, but does also apply to first responder personnel globally. So the newspaper cutting that you can see was taken from Italy, where officers are deploying tear gas to tackle disturbances in the wake of the coronavirus. The respiratory threat in this case is tear gas, which is an irritant to the eyes, the lungs and the throat. And therefore, first responder personnel globally will generally deploy a full-face air purifying respirator and suitable filters to ensure that they are not affected by the tear gas. I've also included a well-known event, which you can see highlighted, which took place in my home country, the UK, the aftermath of which is shown in that picture, where a former Russian military officer and his daughter, known as the Skripals, were poisoned in Salisbury by the nerve agent Novichok, which is a particularly nasty and toxic agent. This event led to a huge cleanup effort, made even more difficult by the fact that as Novichok spreads easily via touch, but is at the same time very difficult to be seen, and that raises obviously its own unique challenges. Due to this, the Novichok was spread throughout the city of Salisbury and required cleanup by teams deploying specialist PPE, which you can see on screen. And to give you a bit of idea of just what that involved, some 13,000 hours were spent in that PPE as a result during the whole cleanup operation. Another threat which is faced with increasing regularity is the threat caused by methamphetamine or meth labs. The production of meth leads to the production of toxic byproducts due to the usage of volatile chemicals, which means first responders entering an area like this require respiratory protection, typically in the form of an SCBA. I've also included an example in the bottom right-hand corner of an accidental release, which can happen due to industrial accidents, for example. As we in our home countries become more and more globalized, industrial chemicals and subsequently waste increasingly travel cross-country. This does unfortunately raise the risk of an accident leading to the release of a material which is potentially hazardous. A good example of this is chlorine, which has a huge list of applications, so from usage in water treatment facilities in certain geographies to help disinfect the water, to local swimming pools and leisure centres, as well as manufacturing PVC, which is used in window frames, car interiors. And it's actually been used as a chemical weapon historically as recently as the 20th century. To put this in perspective, 85% of all pharmaceuticals actually contain chlorine, and that just shows you just how much it's being used globally. Chlorine is often stored and transported as a liquefied compressed gas, which turns into a greeny yellow gas when it comes into contact with the air. And as you can see in the image in the bottom right hand side of the page, you kind of get that cloud which people generally recognize. And chlorine is a really highly toxic material. A recent example in which escape hoods actually were deployed by lawmakers was during the recent Capitol riots in the United States, which you probably recognize and can see in the pictures on the screen. Although the lawmakers themselves, not explicitly FR personnel or first responder personnel, they have close protection details assigned to them to help protect them in such events as these. The final event that I wanted to briefly discuss is in the top left-hand corner. So following the September the 11th attacks and the subsequent collapse of the World Trade Center, beyond the sort of more immediately obvious hazards and dangers that resulted, there was at the time perhaps a lesser known respiratory threat, which was caused by building materials, electronic components, and furniture that were pulverized and then spread over the area as a result of the impact and the subsequent fire as well. In the months that followed these events, toxic dust, including carcinogens, continued to spread and has been linked to health problems in the time since this event. The reason for compiling all these events is to demonstrate that, due to the very nature of their role, first responders globally are faced with a wide range of respiratory threats, some of which they may be prepared for or have intelligence which allowing them to prepare for, whereas others can happen completely without warning. The potential threats are diverse and require different forms of RPE to suit each individual situation. To build on the previous slide, I wanted to spend a short amount of time comparing the wider portfolio of respiratory protection which first responders may use or have available prior to focusing in on escape devices in particular. So this respiratory protection is generally split into two major groups. The first of these is filtering devices. So the key with these devices is that they filter ambient air via a filter or a canister and remove harmful substances to protect the user. Traditional gas masks fall under this category, along with escape hoods or air purifying escape respirators, or APERs, as you might hear them mentioned. Both APRs and APERs are non-powered respirators, so the users draw air in via their lungs without the assistance of a blower motor. Devices that utilize a battery-powered blower to help draw air through the filters and in turn into the user's lungs are known as PAPRs, or powered air purifying respirators. Although these devices have the advantage of taking some of the burden away from the user and having to actually draw that air through the filter, they still utilize filters to purify ambient air and therefore fall under that same category as the others that you can see on screen. The other type of respiratory device category is breathing apparatus, or as most people refer to it, BA. So these devices, rather than filtering ambient air, they utilize a cylinder full of compressed air to ensure that they're completely independent of the atmospheric air. An SCBA, or self-contained breathing apparatus, is one of these devices, and it's most commonly used or maybe most commonly associated with firefighters globally, as the fact that they have their own supply of air transported on their back means that they can be used in an oxygen deficient environment, such as you'll see in a fire, for example. Breathing apparatus generally have a higher assigned protection factor, meaning that they can be used in a situation that's immediately dangerous to life or health, or IDLH. To give you an idea of the difference between these devices, A half mask has an assigned protection factor of 10, and a full face air purifying respirator has an assigned protection factor of 2000, whereas SCBAs with a full face piece have an assigned protection factor of 10,000. So it just gives you a bit of idea of how the protection factor does increase between these different devices. The different types of respiratory protective equipment all have their own advantages and disadvantages, and the selection of RPE comes down to a range of different factors. So the following items, which I've shared on screen, are things to consider when buying and selecting RPE, and some of the things that first responders do consider when selecting and purchasing their RPE. So the potential threat scenarios a user might face is obviously very key. So for example, if an individual is likely to be entering an area of high concentrations of hazardous chemicals, so perhaps when cleaning up a former methamphetamine lab, for example, and these are actually generally considered a hazardous waste site because of the toxic mix of chemicals that go into the production of meth. It's likely that in this situation, an SCBA will be used due to the elevated protection factor that it offers, as I mentioned, along with the fact that it does have a lesser breathing resistance due to the need to draw air through a filter, for example. Training burden is also a factor to consider. So with a more complex device, generally comes an increased training burden, which adds to the cost of ownership of that device, as well as the time required to be able to use a device safely and effectively as well. Some devices, like APRs, for example, require an annual fit test to check the device fits properly, which in turn adds further time and administrative burden to a user group. Total cost of ownership is of course very important, which includes the initial purchase price and then the cost of maintenance and training, as well as the effective life cycle of the product. Generally speaking, an SCBA will be the most expensive device that we've talked about, with cost as a very general rule increasing with assigned protection factor. Size and weight of the RPE is also an important factor to consider. So as you can see in the picture on screen, where the operator is utilizing our combination system, an SCBA is a large device, and due to the weight of compressed air, it's also actually very heavy as well. This makes it difficult if a user needs to move quickly for their role, as well as being difficult to perform just simple tasks like driving, for example. If a device needs to be carried around at all times on the person when not actually being deployed, it's important that it's small and that it's light, and it doesn't interfere too much with their particular role. I imagine almost everyone globally of a certain age at least recognises what a gas mask looks like, whether that be due to images from films or global news. I would recognise that something like this, the C50, is in fact a gas mask. Less people, however, would probably recognise what an escape hood is, and maybe would put it in the same kind of category with gas masks and refer to it as a gas mask under that same grouping. However, escape devices like the NH15 and the CH15 are slightly different, and I've got an NH15 here, which gives you a bit of perspective to the picture on screen with relation to size. There are different types of escape device out there, but the most commonly used is an escape hood, which will probably be which we will be focusing on in today's webinar. Although in a lot of cases they offer similar protection to traditional gas masks or air purifying respirators, they are very different devices. An escape hood, like an APR, filters the ambient air via filters, which generally consist of a particulate filter and then an activated carbon bed to protect the user from any airborne threats and allow what's known as self-rescue. This self-rescue, or the escape part of escape hood or escape device, is the key element, as it means that this is a device to leave a scene safely rather than enter into a hazardous area with the intention of rescuing others or conducting what's defined generally as work. However, in terms of form, fit and function, they're significantly different to gas masks. Escape hoods are generally classified in 15-minute intervals by both NIOSH and European standards, meaning escape hoods are given a rating such as a minimum of 15 or 30 minutes of duration. They're also generally single-use items with filters that are fixed to the unit and cannot be replaced in the same way that they can on an air purifying respirator, which is obviously a reusable device. Escape devices have a number of distinct advantages over some of the other respiratory devices we discussed, which makes them well suited to the first responder market. Hopefully you can see that I've listed some of those on the screen. So starting from the top, escape hoods have a minimal training burden. So for example, the NH15 has a short, approximately 15-minute video to train users on its usage, and it's supplied with user instructions located on the foil packaging on how to use the product. This simplicity makes it attractive as it offers obviously a cost saving and a time saving. And similarly, unlike a traditional respirator, due to the different method of sealing, escape hoods do not require an annual fit test, reducing that burden on first responder users and simplifying that whole ownership process even further. Escape hoods are also very quick to don, with NIOSH requiring them to be donned in under 30 seconds. This is due to an intelligent design on the hood and means that there's minimal steps to deploying the hood on the user's head. Escape hoods are also essentially maintenance free during the product life cycle. There's generally no replaceable parts, and the only maintenance required being ensuring that the foil bag is not compromised periodically. One of the biggest advantages of escape hoods compared to traditional gas masks, however, is their compact size. So for example, a packaged NH15 is only 6 inches tall and weighs just 625 grams. This means it can be carried at all times without interfering with a first responder's role. So whether it be stashed somewhere strategically, so for example, a patrol vehicle, or perhaps carried on the user's belt or thigh mounted. This means a user can have respiratory protection with them at all times, and in contrast to a traditional APR or gas mask and SCBAs as well, which are all much bulkier and much heavier, making carrying them at all times more awkward and less attractive as a solution. So what an escape hood allows is for users to have a CBRN protection solution on their person at all times, and therefore leave a threat scenario safely. To build on the previous slide where we talked about some of the advantages of escape hoods, I wanted to expand on the points surrounding in particular the ease of use of an escape hood. Hopefully you can see on the right of my page in the video the ease of donning as well as the steps to deploying an escape hood, which in this case in the video is an NH15. And you can kind of see the steps to don the NH15 in the lower part of the screen. As this is an escape device, ensuring that it is quick and easy to deploy are crucial points on an escape hood, and separate it from a lot of the other RPE which we discussed earlier. As I mentioned, both NIOSH and European standards require escape hoods to be donned in less than 30 seconds, and we've actually seen trained users don them significantly quicker, in less than 10 seconds in some cases, which means you can go from that packaged product to having that full respiratory protection very, very quickly. There is also a minimal training requirement, as I mentioned, with a quick fitting guide located on the foil bag, similar in style to perhaps those seen on the back of the chairs on an aircraft, for example, along with that short training video which is available, which covers the donning and the doffing process of the hood in a little more detail. This gives the user the knowledge needed to deploy the hood safely when it's actually required, and separates it from APRs and other respiratory protective equipment, which requires significantly more training. The final point I wanted to mention was the fact that escape hoods, like the NH15, can be worn with both glasses and long hair, which make them well suited to a range of different users. Having provided some of that background to escape devices and an overview of the advantages and protection they offer to first responder users, I wanted to use the remainder of the time we have today to discuss some of the more specific cases where escape hoods can and are being used by first responders to protect them in the situations that they can and do face as a result of their roles. The first one that I wanted to focus on, and probably one that we often visualize when you mention the word first responder, due to their visibility on the streets around the world, which is patrol officers. Patrol officers are often some of the first on scene to a wide range of different events resulting from emergency calls, so whether that be a disturbance at a property or something unfortunate like a terror incident, which we discussed earlier. This role, therefore, as I touched on earlier, can bring you into contact with a real wide range of different respiratory threats. When these officers enter a property or respond to an event, they do not know what they're going to face, and therefore being prepared for a wide range of different chemical, biological, radiological, and nuclear or CBRN events is key for their role. However, due to these only representing a small part of their role, CBRN events are probably unlikely to be at the forefront of any patrol officer's mind. One of the key examples of threats that patrol officers may regularly face is the risk posed by illicit substances. The rise in prevalence of synthetic opioids presents such a threat, and there's been numerous reports of officers falling ill following inhaling fentanyl, for example, the risk of which increases in poorly ventilated areas. In a situation such as that, where the officer may perhaps fall ill very quickly, and maybe other responding personnel may not know what the cause is, they may deploy respiratory protection at that point, and an escape hood is a good solution, have been able to carry that around with them at all times, and ensures that they are not overcome by whatever that threat might be, whether it be fentanyl or something else. There's a wide range of different events which patrol officers can be faced with, which present a respiratory threat, and in a lot of cases, for the responding personnel, that threat might actually be unknown. Carrying an escape device like an escape hood on the person or in a patrol vehicle ensures that patrol officers can be prepared for respiratory threats that they might face. So often patrol officers and police personnel worldwide are issued with an air purifying respirator or a gas mask. However, due to the size of these, when they're not actually in use, they are often difficult or cumbersome to carry on the person at all times. Escape hoods, on the other hand, they're much smaller, and they can be easily worn on a person, whether that be on the leg or the belt, or perhaps stashed strategically inside a bag or a vehicle, with minimal interference to their role. They're low profile and they're discreet to ensure that the public are not alarmed, and it won't draw attention to them. And when you look at something like the NH15, it doesn't kind of raise alarm in the same way that perhaps carrying a gas mask might amongst public. They're always ready to be used, whereas APRs need to be checked, need to be maintained and fit tested, whereas escape would stay in their package state until they're required and only have a very minimal training requirement. This minimizes the burden on the user, and as I mentioned before, it's unlikely that kind of respiratory threats are sort of front and center of any patrol officer's mind, and having something like an escape hood gives them that peace of mind and allows them to focus on other parts of their job role. The Avon Protection escape hood line has actually already been adopted by global agencies for use among patrol officers. So most notably the New York Police Department, due to the compact CBRN protection that it offers, and it ensures that they can be prepared for a range of different respiratory threats that they may face due to their role. With any kind of event, and as discussed on the previous slide, typically the first on scene for any kind of incident are generalist first responders. So whether that be patrol officers, firefighters, or EMS, or paramedics, for example. Often the kind of incidents that I discussed on the previous slide, paramedics might also be responding to, and therefore require respiratory protection as well, as they're likely to be responding to incidents, in tandem with other first responder groups. Avon Protection has actually worked very closely with different ambulance services globally, including ambulance services in the United Kingdom. I wanted to use this slide, however, to focus on the potential for a mass casualty event and the repercussions that has for first responders. An event like that, which can cause a large number of casualties, can result from a number of different causes, often involving a respiratory threat, whether that be an industrial accident, a terrorist attack, a natural disaster, or perhaps an attack by a hostile state. An event like that will involve all first responder groups and have wider implications than wider implications than only the immediate responding groups on scene. Initially, for the first on scene, having that respiratory protection is important to ensure that they're safe. And as we've discussed, escape hoods provide a good solution for these users, whether they be police or EMS users, to ensure that they're protected. Escape hoods, due to the ease of donning, can also be used to evacuate casualties if required. And if the casualty is perhaps in an area where they're still at risk from whatever the release material might be, an escape hood, if donned on the casualty, can help provide a solution to help prevent further inhalation of hazardous materials during that recovery process. They're quick and easy to deploy, meaning a first responder can potentially deploy on both themselves or a casualty for evacuation, or they can be potentially stashed for anyone leaving a scene to collect and deploy. Certain locations may stash strategically escape devices in the case of such an event, such a disaster, such as stadiums or perhaps high-profile buildings or infrastructure. Escape hoods can provide a emergency respiratory solution in these events. Being small and light, they can be both carried on the person or stored in a particular location to ensure there's that on-hand, ready-to-go protection solution, which is, of course, easy to use, which is very important in that kind of situation. They offer wide protection against a range of gases and toxic industrial chemicals and materials, as well as being tested against live chemical warfare agents, meaning they're ready to deploy for the broad spectrum of potential threats that first responders can be faced with. The final group or scenario that I wanted to discuss today before I open up for questions was civilian users. So although not uniformed first responder personnel themselves, the user groups that I'm going to focus on today work closely with first responder personnel, maybe through that faced with some of the same risks. There's also a wider range or wider use case of escape devices in industry, ranging from pharmaceuticals to petrochemicals, which I won't be discussing today, but is worth bearing in mind. The first civilian scenario that I wanted to discuss was that of close protection or VIP protection. So high net worth individuals or public figures, so whether that be politicians or business leaders, are often assigned or have a close protection detail. So for the President of the United States, for example, the Secret Service protects the President, whereas here in the UK, the Prime Minister is protected by an arm of the Metropolitan Police. And other countries also have specialist groups tasked with protecting their leaders. Due to the high profile of these individuals in the public eye, they unfortunately may be at risk from attack both domestically and on foreign visits, and therefore need to be prepared for a range of eventualities, including respiratory threats. We saw just this year the example I mentioned earlier of the Capitol riots and how escape hoods were deployed to protect lawmakers inside Washington. The close protection details who protect these individuals often are an arm of the police, but this does actually vary from country to country. A slightly different group who may also require respiratory protection are civilian personnel working in police stations and departments. So in some police departments, due to their size, they may actually have a significant number of civilian support staff. So for example, just to take the Philadelphia Police Department, it has around 800 civilian personnel supporting 6,300 sworn officers. Police departments can unfortunately be at risk from attack due to their position in the community, and whereas sworn officers are generally issued some kind of respiratory protection, the same is not always the case for civilian personnel who may be at risk in the event of an attack. For both these groups of civilians, an escape hood offers respiratory protection that they can have on hand in the case of an emergency without needing regular maintenance and fit testing. The compact size of an escape device means it can be easily stashed strategically, whether inside a building, for example, under a table or in a desk, or inside a government vehicle for use when required. When it's required, it's simple to deploy and it will allow a user to safely escape the scene and the threat at hand. So thanks everyone for sort of listening to those slides. But before finishing up and letting anyone go, I wanted to open up for any questions that you might have. So as I mentioned earlier, these can be submitted using the question bar located on the right-hand side of your screen.
Thank you, Tom. Really great presentation. We did have one question come over regarding if escape hoods can be reused.
Hi, that's a good question. So kind of, as I mentioned, that's one of the key differences from an air purifying respirator is the fact that it can't be reused, sorry. And that's largely due to the same kind of reasons as why you change a filter on an air purifying respirator. So once the filter becomes into contact with the atmospheric air, there is that issue of the sort of degradation of the carbon inside the filter. So for that reason, once you open the escape hood out of its foil packaging, which I showed on screen, once it's sort of been used and it needs to be disposed of, it can't be reused, and those filters can't unfortunately be replaced like they can on an air purifying respirator.
Thank you. Another one that came over was regarding sizing. If you can mention again the sizing for the escape hoods, is it one size fits all?
Yeah, that's a good question. So as you may already be aware, we have 2 escape hoods as part of our Avon protection portfolio. So we've got the NH15, which has been around for a while. It's been around probably over a decade now, and that's three sizes. So extra small, regular, and large, and the sizing is done in accordance with the neck size. So similar the way to maybe you buy a shirt, and I think it's 12 to 13 inches is extra small, and then 13 to 18 is your regular, and then 18 to 22 would be a large. We have actually just released or launched, a new escape hood, the CH15, which I can show you here for anyone who hasn't seen it. So this is something we have a CE marking for at the moment. Unfortunately, we're just working towards NIOSH approval at the moment, so it will be sort of more widely seen in the Americas later in the financial year, or later in the calendar year, sorry. But this is actually sort of taking some of the lessons that we've learned on the NH15, and one of the things that we wanted to improve upon was making it a universally sized product. So when you look at the CH15, you'll see that it is only offered in one size, and it's a one size fits all product. So to answer your question, there's two different products, and one has 3 sizes, whereas the other is a one size fits all product.
Perfect, thank you. A few more have come across. The next one is, how often do you service an escape hood?
So yeah, so as I kind of mentioned, there isn't much servicing to do, so it does depend a little bit on how you're using it. So both the NH15 and CH15 are 5-year shelf life products. So if you were kind of using it, we would probably, and kind of transporting around with you every day, we'd probably recommend that you check the vacuum hasn't been broken, or the foil packaging hasn't been broken, probably daily, but it does come down to the sort of standard operating procedures of whichever agency that user represents. So that's really the only maintenance there is on the product, just checking that, and then obviously making sure that it's within its 5-year shelf life, it hasn't sort of expired. That's the only other thing, and that's kind of the key. Well, one of the key advantages of an escape hood is the fact that you really don't have any maintenance. You don't have any replaceable parts. You don't need to do an annual fit test, and it just reduces that burden on the user. It makes it's a ready to deploy device, which you can sort of take out and use when required, without having to worry about kind of maintaining it.
Thank you. Next question we have is, has the combo hood been discontinued?
So the combo hood is not something we currently are offering. So yes, we kind of have found that the main threat that people are worried about is kind of your organic vapors and your sort of CBRN threats, rather than maybe carbon monoxide. So for that reason, we've kind of stuck with just our standard CBRN escape hood, rather than offering the combo variants.
Thank you. There's a few more here. Next one is, can children wear escape hoods?
So there is certain escape hoods that are specifically designed for children. It does depend on age and very much so on the sort of sizing. So it's quite hard to answer without knowing sort of the size of the person that we have in question here. But if it was kind of below that 12 to 13, or that inch neck and that size, we wouldn't recommend that it's used. There is other sort of bespoke hoods offered by other manufacturers that are for children, but we probably wouldn't recommend using the NH15 or CH15, particularly on small children.
Thank you. And the last one we have here is, how long can these be worn for at a time? So
as I kind of touched upon, they're sort of rated in 15-minute intervals. So both the NH15 and CH15 are a minimum of 15 minutes of protection. So if you kind of the certifications of both NIOSH and the test standard that we use here in Europe, BS8468, approve it for 15 minutes of usage. So after 15 minutes, you should be removing it and disposing of it, or if you're still in like a threat scenario, at that point you would be required to sort of put another hood on. That's not to say that I understand that kind of often these kind of emergency style situations, you're not stood there watching your watch and you see 15 minutes is up, and so it's not really like that. So the hood won't sort of it's not going to disintegrate or start to fall apart or fail after 15 minutes. the 50 minutes rating is something that's defined by the test standards that we have the hood approved against. So NIOSH and then BS 8468 is a test standard here in Europe.
Thank you, Tom. That looks to be all of the questions we have received. So again, great presentation. Thank you, and I'll pass it back over to you.
So just to sign off, I wanted to say thanks again, everyone, for joining and for your time today. Appreciate you taking that time to join us and for the questions that you asked. If you do have any further questions on our escape hoods or any of our other products, please do feel free to contact us using the details located on the screen. So following this webinar, we'll be sharing a recording of the session today, along with our white paper on escape hoods, which will provide a little more information on some of the items that we discussed today. So again, many thanks for joining and stay safe, and thank you.